Good morning, good afternoon, and good evening, ma'am. My name is Lalde, and I'm taking Bachelor of Science Civil Engineering. and I would like to appreciate for your kind consideration, giving me this second chance to retake this completion exam. I'm really glad that you have been helping me from this, even though we are facing a hard time. You have been giving me opportunity for filling up this completion exam once again. I really appreciate for that. And firstly, we have to complete this all, but unfortunately I have difficult time when it comes to connection or any technical error, so I could not make it earlier because of this technical problem and some issue. That's why I submit that it's a bit late. I hope you understand for in this situation as well, and I would like to request that your consideration for my a bit late submission too. And first of all, let's start with the first module, lesson 1, which is simple stress. As of definition, stress is defined as the strength of a material per unit area or unit strength. It is the force on a member divided by area, which carries the force formally expressed in PSI, which is stand for Pascal inch square, now in Newton per millimeter square or megapascal. As we can see here in the formula for simple stress, as simple stress equal to P is stand for applied normal load unit in Newton, and A is stand for the area unit in millimeter square. Second, normal stress. It is either tensile stress or compressive stress. In other words, forces parallel to the area resisting the force caused hearing stress. It's different to tensile and compressive stresses, which are caused by forces perpendicular to the area on which they act. Here I have provided a simple normal stress equation, which is normal stress equal to V over A. V stands for resultant shearing force. A is stand for cross-sectional area. And then bearing stress. It is the contact pressure between the separate bodies. Continuous beams are those that rest over 3 or more supports. As we can see here, I provided a diagram that is referring to simple stress diagram. And for the first problem, which is I just created for my own to complete this problem solving. So basically I have to find out the member of C to D from A to D. So basically it's indicating the arrow is the load force is acting, which direction, it's up direction or downward direction, which means upward direction, which is mean is positive, and then we can consider in sign convention in positive. And if it's downward direction, we can consider as a negative direction sign convention. So I have provided 120 kilonewton in upward AY and 100 in downward kilonewton. So let's solve for this problem. So I have separated into 3 figures that's based on the joint A, which is I have finding out slope, x direction is 4 and y direction is 4. So we can find it out. Hypotenuse, computing square root of x square 4 square and 4 plus y 4 square is equal to 5.65. By the way, I forgot to write here for meter. It's the height of this B to C is 4 meter too. So normally I consider that clockwise is positive sign convention and counterclockwise is negative sign convention. So upward direction is positive, so summation F1 equal to 0. So normally it's 120 is going upward, so it's positive, and F force at AB is rotating counterclockwise, so negative. So therefore we get FAB is 169.50 kilonewton is compressive member force. At joint B, in the same method apply into the joint B, this diagram. So FBC, we have to find it FBC. So we same formula that's applied for joint B. So 169 FAB times 4 over hypotenuse 5.65 negative F of BC. So we get 120 kilonewton in is tension compressed strength. And at joint C, it's we are going to find for joint C FCD for the final requirement. So we computed estimation F of y equal to 0. It's counterclockwise, positive going upward direction. So 120 negative 100 going down negative negative F of CD. CD should be going downwards as sign 51.13. So we computed 4 F of CD is equal to 25 kilonewton compressive. And lastly, we have to find it out the simple stress. By using the formula of simple stress, is equal to load factor F over area. So we can substitute the value of F of CD 25 kilonewton time over area is 1200. So we come up with 20.833 Newton over millimeter square. Is converted into kilonewton is 20,833 kilonewton over millimeter square, which is the answer of simple stress. Secondly, and simple strain. As a definition of simple strain, also known as unit deformation strain, is the ratio of the chain in length caused by the applied force to the original length. As I provide here, and the equation of simple strain is delta equal to deformation n over length, original length. E is stand for other word is modulus of dimensionless. So as a problem, I'm going to draw these three links which will support loads. I give it load is P equal to 10.25 kips, and at the horizontal bar B to D will not be deformed. I estimate the development stretch area all over is A to B is 0.35 inches square. From C to D is 1.15 inches square. So I'm gonna use modulus E equal to 29 times 10 to the power 6 psi, pound per inch square for all the steel links. So here what is required is axial strain sustained by link C to D. So let's compute and separate into two section for E and E prime, and then we have to compute for direction of forces that's acting on this beam. So because of symmetric nature, RB is equal to RG. So we split into two sections for this beam. So we normally have to multiply by 2 RB plus RE is equal to 10 point, given load is 10.25 kips. So it's, let's say it's equation 1. So let's find out for compatibility delta E B is also equal to delta E to F. So we have to find it out the value of RE and RB. So we provide the formula PL over AE times AB equal to PL over AE times EF. So we substitute all value here, and then we will be getting RE equal to 4.832, RB let's say in equation 2. So let's solve for equation 1 and 2. So we substitute values here for equation 1. So we got RB equal to 1.50 gives, and substitute in equation 2 the value of RB equal to 1.50 gives, and we got RE equal to 7.248 gives, and we have to find out delta C to D. So first of all, we have to find, first thing is delta AB is equal to RB over AB. Its RB is 1.150 and the given AB is A to B area is 0.35, so we come up with 4,286 pound per inch square. It's tensor. And then delta E to F is RE over AEF equals 7.248. The given area is 1.15 inch square, so we come up with 6,303 psi compressive. And finally, we want to, the value is delta CE. So delta C is over E is given 29 times 10 to the power 6 psi. So we normally cancel out the units psi, so it's unitless. 1.478 times 10 to the power 4 is the final answer for this problem. So let's move to number 3 lesson, which is torsion. Torsion is considered a bar to be rigidly attached at one end and twist at the other end by turn or twisting moment T, and equivalent to force time distance, which is applied perpendicular to the exit of the bar shown in this we can see in here in the figure. And so we are going to find about A to E, or E gear twisted of gear E to gear A. So I have provided the loadings value on each of section from A to E. So for example, for section A there is 10 Newton meter. It's going let's say clockwise, so I assume that is positive sign. If it is counterclockwise, we have to assume it's in negative sign. So 10 Newton meter is counterclockwise and 25 Newton meter is clockwise to the same so direction. So it's 10 plus 25 is 35 Newton meter, and 35 minus 50 is negative 15 Newton meter, and negative 15 Newton meter is same different direction of at section E, so it's 60. So negative 15 Newton meter plus 60 Newton meter is supposed to be 45 Newton meter. It's error, so I have to fix it before submitting. This is error, it should be 45 Newton meter. So as of solving for this diagram, it's come up with for a simple shear diagram that I have provided here. It's 10 Newton meter is going forward, let's say, and 25 Newton meter is going forward too, but 15 Newton meter is going opposite direction, and this is 60 Newton meter is going forward, and this is 45, should be 45 Newton meters going opposite direction. So it's meaning that we have already got the value for T. DE is, it should be 45 Newton meter, and this is should be 45 or not 50. Okay, 45 minus 60 is negative 10 Newton meter, and T DC plus it should be 50 Newton meter. Is negative 50 plus 50 is 35 Newton meter. And then lastly, TBA B to A is TCD minus 225 Newton meter. It should be 10 Newton meter. Here is error, it's 45 Newton meters plus. So by using the equation to find out the angle, as delta E over A, E to A is equal to 1 over J G times summation d r. So we substitute the values 1 over 1 over 32 for torsion equation by each 40. This is error 1, error 2. Here it should be 40 millimeter. It's loaded in top, so I will correct it later. So 28 times 10 to the power 3, substitutes all value here is 45. So normally we get is 0.021 rad. Okay, this is incorrect answer. I will provide it. It's 0.021 rad. It's converted into degree mode, which will be 1.203 degree, which is the correct answer, 1.203 degree. And module 4, lesson 4 is shear and moment of beams. A beam is a bar subject to forces or couple that lie in the plane containing the longitudinal section of the bar. As a problem, here we have to find out shear and moments that support that hinge is at section B, and at section D is roller support. And then the moment direction is going counterclockwise at A is then 100 kN, and supported load is acting on section C is going downward 60 Newton meter respectively. So as a solution, we know that summation f of y clockwise is 0. I will substitute for all to find out vertical forces. So by plus dy minus 60 times 60 minus 100. Actually we cannot use this 100 yet, so it's 50 is loading, so 50 times the length is 3.5 equal to 0. So we now put equation 1 is 235 kN. At summation ma equal to 0, it's for moments calculation. So 100 negative 100 plus 60 times length 2 minus dy times 2, length 2 plus 4 plus 50 times 3.5 times 6 length plus 3.5. It's separated into two sections, so divided by 2 equal to 0. So end up with dy equal to 172.03 kN. It's going upward direction. And from equation 1 we can get by the value of by, which is by substitution dy, so it's an upward 62.97 kN upward direction. Shear force calculation is shear force at A is 0 normally, because there is no supports acting on shear force at A, and shear force at B is same with by acting on upwards is 62.97 kN. The shear force at C is by negative, cy is going downward. So as for at CB is going 62.97, and then 60 is going downward, so it should be negative, it should be positive. So therefore we got is 2.97 kN. It's going downside, and shear force SD is 62.97 by minus 60 plus 172.03 is dy is going upward dy. So we got is 175 kN. At the moment of A, MA is normally equal to 0, negative 100, and B, the moment of MC is equal to negative 100 kN meter 2. So we find out BC is equal to on 25.94 kilonewton meter, and then BMD equal to 37.82 kilonewton negative kilonewton meter, and lastly BME is equal to 0. There is no acting on BME load. So lastly, I provided here for the calculation for shear moment and shear and moment diagram. That here I just substitute and draw for the figure of shear diagram, and here is moment diagram is at point at A is 100 kilonewton meter, and going up 25 point, it should be 25.97. 25.94 kilonewton meter, and negative 37.82 kilonewton meter at 0 kilonewton meter. And the fifth lesson module is stresses in beam. Forces and couples acting on the beam occurs bending, flexural stresses, and shearing stresses on any cross section. Any cross section of the beam that will be deflect perpendicularly to the longitudinal axis of the beam. It said that to be pure bending, the force produced will be bending moment, and the bending is also called in, for example, ordinary bending. Here problems that we are going to find the minimum height of the beam by using flexural formula or other flexural stress formula that should not be exceed that 20 megapascal. So here I have provided a figure for these stresses in beam computation. Then summation moment at CY, moment at CY. We have going to find it's an about 27, 5 times length 5 times BY, 5 times BY equal to 3, length of 3 times 10 is going counterclockwise. Negative should be negative 3 times 5, 3 times 5 times all. Compute this length is 7, so 27 kilonewton. At moment B, we are find going upward direction clockwise. So 5 times CY plus my CY. This is BY. Let's say this is CY. CY time. This is 5, 2, 3. So CY time 10 is going 10 downward kilonewton. Yeah. So time plus 2. The length of the beam is 2 times 5 times 7, combined 7. So CY and I with 18 kilonewton. So actually we can check it off all the direction going on this beam. It is 27 plus 18 plus negative 10. It should be 27 plus is 5, 40. It should be 40 times 43 times 60, 5 times 3 times 15, and 10 25, and then gonna be 5 times 3 15, so it should be 0. Therefore we have to find it out at equation of f of b equal to mc over I, because we want to find the minimum height of the deflection beam. So I use it 18 kilonewton meter. It's the high peaks that's reaching out on the beam. Shear diagram and moment diagram is 18 kilonewton meter. So C is equal to 1/2 of H. So I equal to BH cube over 12 equal to BH 60 H cube over 12. So we substitute in the equation 1. So that 20 equal to 18 into 10 to the power 1000 square 1 H over 2. So we end up with A square 90,000 and H is 300 millimeter for this diagram. And deflection of beams. The deformation of a beam is usually expressed in terms of its deflection from its original uploaded position. The deflection is measured from original natural surface of the beam to the natural surface of the deformed beam. The configuration assumed by deformed natural surface is known as elastic curve of the beam. So the thing is, I'm going to find it by using deflection beam in couple edge moment at, let's say, 150 Newton meter. Adds the value of F2 and MC that we are going to find by using conjugate beam method or area method. So the 450 is acting on this beam is going downwards. A roller support is acting on section A, and beams hinge support is acting on section D, and moment is acting on section C at 150 Newton meter. As a solution, so moment we have to find at D first. Moment at D, we have to find it out. Moment is as a counterclockwise. So 4 times at D, it's 4 times. This 4 times R1 is going counterclockwise equal to 3 times 450 plus 1 times 150. So at another 375 for R1 is Newton. Acceleration moment at A is 4 times R2 plus 150 equal to 1 times 450. And its common wood R2 is 75 from the conjugation beam, and we have to split into the length equation or the moment equation for this conjugated beam. So we find our the length, it should be 6.3. It's the highest peak of this moment diagram is 1125 Newton meter and 90 Newton meter. So we substitute all the values here, and we find we have got F2 equal to 350 Newton cubic meter, and then we have to find MC. It's equal to 1/2 1 time this one, then is 75 times 1/3 times 1 negative 1 times F2 given F2 is. That's why we are come up with MC equal to negative 337.5 Newton meter cubic. So let's move on to the next topic, which is restraint beams. In addition to the equation of static equilibrium, relation of from beam, the geometry of elastic curve are essential to the study of indeterminate beams. Such relation can be obtained from the study of deflection or rotation of beam. This section will focus two types of beam, that's proposed beam, and the fully restrained beam. As of the problem that I'm going to find out for the elastic curve and shear diagram and moment diagram. So acting on this beam, a load is 5 kN meter. At moment at A is acting counterclockwise, and moment at B is acting on clockwise. This is, I assume that RA is supporting is going upward direction and RB is going upward direction too. So fix and moment at from A to B. I have to find for moment is negative 5 times 10, 7 plus 3 tenths square over 12 negative 30. It should be 30 kilonewton. Times 3, it's times 7 square over 10 square. So we come up with 85.77 kilonewton meter at moment B. So free structure moment. So RA is 5 times 10 over 2. 30 over 30 times 3 over 10 equal to 34, should be kilonewton. RB, from RB is 5. This is 5 times 10 over 2 and 30 times 7 over 10. So this is 46 kilonewton. So mx is 34. It's all in all 34 is RA. It's equal to mx equal to, that is 34x negative 5x square over 2. Is, let's say it's equation 1. And here I have provide elastic curve. That's maximum reaching number is 115.6 kilonewton. This is shear diagram. Start from 34.78 kilonewtons going upwards. It's negative. It should be negative 3 points going downward. 3.52 kilonewton and 33.52 kilonewton and 48.52 kilonewton. At the moment, start with 60, negative 60.57 kilonewton and reaching out 115.6 kilonewton meter and ended up 85.77 kilonewton. So we substitute, and by using derivative method or derivative equation, dmx over dx is differentiate 34x negative 5x square over 2 is 34 minus 5 square, cancel it out 10, so 5x. So supporting direction reaction, we compute RA plus this should be RB. So therefore we come up with 50 plus 30 equal to 80 kilonewton. So RA come up with 31.48 kilonewton. At RB equal to 80 minus 31.48, at RA equal to RB is, we assume as x equal to 6.8 meter. That will be affecting for the shear diagram and moment diagram too. Here is R is only 6.8 meter and 3.2 meter. It's different from the original figure. So we got is 34 times 6.8 is x value, so 115.6 kilonewton meter, and m7 is equal to 34 times 7. This is original, based on the original diagram, times negative 5 7 square over 2, so 115.5. A little bit, just 1 point is different from m6.8 and m7 point. So it's applicable to use the beam or any kind of steel bar reinforcement. And additionally, continuous column. As of definition, continuous beams or columns are those that rest over 3 or more supports, thereby having one or more redundant support reaction. as problems, continuous column has shown this here. It will be determined the bending moment, its bending moment, and shear force on it as a function of height, So we have to flip it into different position. So we come up with this diagram that's acting on 80 pound per feet on section A, and 200 pound per feet acting on A, section A. So moment is going counterclockwise at moment at point A. So we compute the reaction. So delta B is equal to delta W. So we have to separate it out by using the reaction, the equation. So delta B equal to the RB times L cube over 3 EI. So we come up with solving this equation, and 2. So we come up with RB equals to 378 kips. And then we have to consider the vertical equilibrium of the beams. So the vertical equilibrium of beams is equal to 0. So A1 plus B1 is equal to 1/2 80 plus 200 times 9. So we come up with AY is A2 keeps consider its moment above A. So MA equal to 0 and MA equal to 80 times 9 times 4.5 or 0.5 times 9 times 120 over times 9 over 3 negative RB times 9. So RB is going to substitute RB values at 378 here. So we got 1458 kilo feet, kips feet. At let's consider into section W1 and W2 in the middle mid-span. So let's say this is X and this is X section. So let's say AX. So therefore 378 BY minus 80 x minus 22.22x. So therefore we come up with negative 431.955 Newton. So there in the second we have to consider is to the section of for the bending moment. So bending moment x mx. So byx minus 80 x square over 2 negative 22.22 x square over then times 2x over 3. So we come up with negative 909.473 kilonewton meter for the final answer. And then lastly, combined stresses including, let's say, modes circle. So I have found one have to create one problem for including mode circles. That's a structure member is subjected to different types of stresses that act simultaneously. Such stresses are axial, shear, flexure, and torsion. Superposition method is used to determine the combined effects of two or more stresses acting over the cross-section of the member. So firstly, axial stress equation is same with simple stress, delta equal to P over A. Let's consider for the problem solving. Let's say element stresses and that is acting on this let's say stress combined beam that will be using for transformation equation and determining for the modes cycle of stress. So I give it up here for 80 megapascal going forwards and 80 megapascal is going backwards. So each two of direction has opposite each of each, and this A, let's say A to B opposite direction has been facing opposite direction. So meaning by using mode cycle methods, I have to compute the center of cycle point. Let's say this is point at A. So delta A is we have to find delta. Let's say XX. This is we have to split into two sections. So we are going to be getting delta xx plus delta y over 2. So negative 80 over 2 is 0 megapascal. So the minimum combined normal stress and plane angle is basically 0. So let's determine at point B. So y minus phase delta yy and delta xy is equal to negative 80, and x delta x and delta yy is 0. For the principle of stress and maximum shear stress, the equation is r equal to square root of quantity delta xx minus delta yy over 2 the whole square plus delta xy square. So we substitute delta xx 80, negative 80 the whole square. It's come up with 0. So r is supposed to be here is 0 megapascal. Yeah, this is mistaken again. So delta p equal to delta a plus or minus r. R is here. We are supporting to find out the values of r tau maximum. So plus 80 mega plus or minus megapascal. Megapascal is we have to computing for principal stresses related to x phase plane. So 2 delta p equal to 10 inverse of delta xy over delta xx negative delta a. So we come up with delta p is 22.5 degree counterclockwise from x phase. So finally we have to compute the rotation of planes for the maximum shear stress. So delta 2 delta s equal to 90 minus 2 delta 1. So delta 9 is 45 degree. So delta s equal to 45 degree. Come up with delta s is 22.5 counterclock from y exit. So this is the answer for the mode circle that's come up with from the computation. This is x direction is negative 80 over 0 0 0 original point 0 80 and 0 and megapascal. So the normal stress and shear stress for 35 degree is delta x is equal to delta x cos square theta and plus 2 delta xy sine theta cos theta plus delta yy sine square theta. So we solve for 20 all the value here, so 27.37 megapascal. In the meantime, delta yy is equal to 0 megapascal. So I hope that's all for my explanation concerned with this requirement. Actually, I have to explain it furthermore detailed, but I guess there's time limitation because it will take longer, so my PC cannot be able to save for the file. So it's a problem for my PC. I've been trying this to save a lot, but I could not save if it is exceeding over 30 or 35 minutes. It will take time, and then it's hard to save or upload any video clip. So I hope you understand, and then you figure it out as well while I'm explaining concerned with this problem solving and computation. All in all, I hope that I have a really hard time to gather this information because it's been a year already, so sometimes I'm facing also other difficult manner. So it's been a lot of challenging in this pandemic. So we all know that every student has been struggling concerned with every situation or learning program through online distant learning. But I appreciate that you've been considered as well, and you give us a chance to be able to really take this exam, completion exam as well. So I really want to thank you once again for your kind consideration, ma'am, and I hope you are keep saying and then doing as well, and then I pray for you also, and then for your family and all members to be healthy life. Everything's gonna be going smoothly, and I want to request for you to me too, pray for me too with the reasons we have been facing. Let's help each other in praying, and then I hope you're gonna be submit this my early completion exam to the office as soon as, so they will be applied to resubmit to the register office, so that they will be update my grades as well, so I will not be having a hard time to talk to the immigration office. It's really concern for us too when we are applying to visa process to the immigration. It's really concern, they will be require a lot of things from us, so I hope you understand as well for this regarding problem solving and everything. If there is a mistake, and also please I will approach. I've been rushing up too much time, so that's why I have make some mistake probably, perhaps, so I apologize for that ahead. Thank you for listening all the time, and may God bless you, ma.